we're starting on 7, right? The one we started last week?
Yes.
Alright, so this is the one for Joseph wiggling his ears. It's hard to say. Do you guys all have your pedigrees on your separate sheet of paper ready to look up here? Let's see, John, would you just read us the prompt one time? And I'm going to sort of follow along with it, showing you guys where it's at and stuff like that, and why it is the way it is. I might stop you, so just be ready.
Okay. Joseph can wiggle his ears. He married a woman named Jonah. Oh,
Joan, yeah.
Jen, we'll go with that. Who can't wiggle her ears. They had 6 children, 4 boys and 2 girls. The girls are the oldest and can wiggle their ears. 2 of the boys can wiggle their ears.
Alright, stop right there for a second. Thank you. So, first of all, we have the oldest on the left, right? Correct? No, we're going left to right in order of age. It said the 2 girls could wiggle their ears, so this is the trait that we're talking about. That's why they're shaded in, and 2 of the boys could wiggle their ears. That's why that's the trait shaded in. Okay, these are all little important things that we need to do along the way. Do you see how we could have drawn that just in that order as it read it to us, basically? I do think that's the easiest way. All right, John, continue.
Girls are always thinking. 2 of the boys can wiggle their ears, and 2 cannot. The younger boys can wiggle their ears. Joseph, the oldest daughter, married a man named John who can wiggle his ears. They had 3 boys and 1 girl. The girl is the youngest and can wiggle her ears. The rest cannot wiggle their ears. Joseph's parents can both wiggle their ears, while his wife's parents cannot.
Perfect. Thank you, John. All right, so out of all that, how many of you got that exactly right on your self-drawn pedigree? Kenny? All right, well, McKinney. First of all, great job. And John, you got it?
Yeah.
Good job.
I wish they wouldn't leave like the grandparents like dead last. So you got the parents up top to have more room.
Especially if you did start drawing up towards the top of your paper. I
Decide
can
to
see
give
why
you
that-
more stuff, more room.
Yeah, so maybe on a few of these, make sure you're leaving yourself space to work, but while trying to keep it spread out, you know, it's a difficult balance. All right. Those of you that didn't get it right, what's something that you did wrong? Did anybody like get it pretty close to right, but just mess something up? Anybody, what happened with yours? Oh, you forgot the grandparents, yeah. Okay, so that's all right. So you got part of it right though? That's good, good job. All right, let's go on to the next one. Everybody done with that? Anybody else need to see that any longer? A little longer? Okay, we'll leave that up for just a little bit longer. Was that right according to what it said?
Yeah, oldest daughter, son-in-law.
Married someone who could not wiggle their ears? Okay, gotcha. That's what the son-in-law is, got a son-in-law.
Oldest daughter married a man named John. So they get married.
Yeah, that's just what threw me off. I thought it said something entirely different. Alright, well if you need to go back over this, we'll go back at the end of this. Let's go ahead and go to number 8. Are there questions? Yep. So if Joseph's oldest daughter had another child, what would be their chances of having a child that cannot wiggle their ears?
30%.
Show your work. So Joseph's oldest daughter could wiggle her ears, and if you went through that, you found out that she's heterozygous for the trait. That means 1 dominant and 1 recessive allele. Draw that as capital W, lowercase w. And she married a woman, or she married a man that could not wiggle his ears, right? So lowercase w, lowercase w. And whenever you fill out that Punnett square, what are our odds here? What are our chances?
It's 50.
50-50, right? So we have 50% of them are entirely recessive, will not be able to wiggle ears. 50% of them are dominant carriers or whatever, yeah. Alright. Number 8. Do you think this pedigree for having dimples is possible? Remember that having dimples is a dominant trait. So, let's see here. We're looking at, right here, is two parents basically. We'll call this the parent generation. They can both wiggle, or sorry, what is it? Dimples this time. They both have dimples, and they have 4 kids. So first of all, when I see this, I'm thinking about, a Punnett square with each, and I can see, the odds of things happening. So yeah, it first of all, so far it's possible. One kid could not have dimples, even though both parents do. We can see that this kid that could not or did not have dimples married somebody else who did not have dimples. Yet they had one kid who did not have dimples, but a kid did have dimples. Is that possible?
Yeah.
So from these two right here, I'll draw it a little bit bigger so everyone can see it. Lowercase d, for both of them. They don't have dimples, they're recessive. What is 100% of this going to be?
Non-dimples.
Lowercase d.
Yeah, so is that possible that they have a kid with dimples?
Yeah.
I mean, if you look at the Punnett square, no.
If you look at the Punnett square, no.
So it's like if you go
So it's
back to
very
like how like common it was, and it
Okay, if it was a polygenetic inheritance thing, right? As you'll see, we're getting to that later. Okay, but if we're talking about like Mendelian inheritance, simple yes or no,
okay.
no, it's not possible, okay? But you're right in the real world context, okay? Most things are related to several different things, okay? But in this case, no, okay? We could go up to the grandparents, but we already decided that it's not possible down here, alright? So, down here it says, no, the parents are all recessive for dimples, so their child would not have inherited dimples. How many of you figured that out before I went over it? Okay, you did, sort of. Okay, cool. Devin, did you? No? Okay. Oh, good job. Alright, 9. Draw a pedigree for the following information on a separate sheet of paper. Alright, let's go to that. Let's see where we're at. Kenny, do you want to read this one this time for us?
Sure. Sam Smiley does not have dimples. His dad and mom both have dimples. Sam had 3 sisters with dimples who were all older than his dad. Sam's mom had 3 brothers without dimples who were all younger than his mom. Sam's grandparents on his dad's side both have dimples. Sam's grandma on his mom's side has dimples, but grandpa does not. Sam, who has 2 younger sisters with dimples. Sam has an older brother without dimples who died.
Okay, so will you reread let's see.
Yeah.
It said Sam's dad had how many brothers or sisters?
Is that a circle?
Yeah. I think there's a error there.
Yeah, it says his mom.
Has 3 brothers. What about his dad?
3 sisters?
Yeah.
Okay, yeah.
Okay.
One of those, this was supposed to be a circle.
Okay.
Anyway. Alright, so you went through, and the really key part here is shading the correct parts. You go through, just make the squares for the males and circles for the females. Following through this. Once we get that, the important thing here is that we're able to put capitals on all the dominant parts. So, already kind of gives it away here on this one. But after that, we're going to go through and put all lowercase on all the recessive parts, and then fill in the information that we want to know or want to find out. So a few of these we can see that are still marked with question marks. We can't really know based on the information given. But we do know that there's at least one dominant from one of the parents, and the other one could be dominant from the other parent, but they could be recessive if they were just carriers of the trait or something, okay? Questions for that? Nothing? Alright. So it says, how is it possible that Sam's dimpled parents have a son without dimples? John? That wasn't a hand raise? So Sam's parents are heterozygous for dimples. Heterozygous means that they are dominant for it. They have the dominant alleles, but they also have a recessive allele. Each one of them has a recessive allele. That means that there's always going to be a 25% chance for that recessive trait to show through if they're both heterozygous. Again, we got capitals going to capitals. Lower. So this is the heterozygous mom or dad. This is the heterozygous mom or dad, either or. Whoops. And each one of these is a 25% chance, okay? Possible, right? Good. C, what is the genotype of Sam? Did Sam have dimples? If you're not sure, read it again real quick or check your drawing.
No.
Does not.
Does not. So recessive for it, which is lowercase, right? That's the genotype. That's all we want to know is just that it's lowercase d, lowercase d.
I started, I never got one finished, so ran out of time.
That's okay. So we're going over now. And then D, what are the genotypes of Sam's grandparents? So if we go back to the chart here, we can see that if we tried to fill this out as much as we couldn't figure out these grandparents, right? We didn't have enough information. We just knew that everybody over here was dominant. Does that mean that it's impossible that they could have had a kid without dimples? It is possible. We just don't know. Over here, we had enough information from the recessive children that did not have dimples that we could figure out theirs. Alright. So that should be able to answer your final question. Make sure you get that filled out, guys. Any final questions on this? Did I miss anything, Miss Mullins?
Yes, you did.
Alright.
Okay, go back one more.
Alright, so we're going to talk about, well, I mean, this is what we have been talking about, it's midway and inheritance, okay? We're going to get into these other types over here that I'll go over in just a second. Alright, so, they have this on their Google Classroom? Alright, so we'll get you guys to this and you'll have to fill this out on your own, stuff like that. Or with a partner, probably. So you should pay attention. What are alleles and how are they expressed? So you're able to click and interact all the way through this thing, right? This is how you're going to come up with these answers. So we're able to look through this. And find it. So for example, it's going to be impossible to see this on the video, I know, but that's okay. You can, when you're doing this, you can even copy and paste answers from the thing. You just got to find it. You got to take the initiative to look for it and read through it. I'm sure you and your partner can figure it out. So we'll just keep going through this together until we can figure it out. All right. So then we got what genotypes would express the dominant and recessive version of a trait. Anybody know off the top of your head?
You can use any letter.
Okay.
Genotypes would express the dominant. Genotypes would express the recessive.
Capital.
Recessive.
Lowercase.
Good. So capital is 1, genotype that would express dominant and capital lowercase still expresses dominant. What about recessive? Lowercase, right? And we can use whatever letter we want depending on what we're talking about. It's best to use a letter that looks different in both its forms. Okay, good. What about how many recessive traits do you possess? Oh, well, we gotta look at this. It says the first 6 listed. So let's look at all these recessive traits. Cleft chin. Well, that's dominant, actually. Yeah, that's okay. And chin without a cleft is recessive. How many of you got a cleft on your chin?
Like the dimple in your chin.
You got a dimple on your chin? I don't think I do. So I got one. Cheek dimples. I have dimples. So that's dominant. Any of you don't have dimples? That's recessive. That's a little bit different. Attached earlobes or free earlobes. So I can wiggle, I got big ears. I can wiggle my earlobes around the part that hangs down, or at least it hangs down on mine. Does it hang down on yours? That means it's a free earlobe. That's dominant. If your earlobe is attached all the way down here, right? Like if you can't really pull that down and off and away, that's an attached earlobe. That's a recessive trait. Any of you got that? Anybody's earlobes attached? I don't know how common or uncommon it is. Freckles. I have freckles.
What if you had like
Seasonal freckles totally count as freckles.
Okay.
Because I know that's kind of how mine are as well. Anybody never have freckles before ever? Connor's never had freckles.
My mom does.
Alright, hitchhiker's thumb. Is your thumb straight or is it curved back more?
So like, Connor, can you bend your thumb farther back at all? Okay, so Connor's is an example of a not hitchhiker's thumb, whereas mine's an example of a hitchhiker's thumb because it bends. Does that make
Yeah.
sense?
What would mine be?
Yours
It's a
is a-
hitchhiker's thumb.
Yep, if it goes
Yeah.
back past
If it bends.
vertical.
Yeah, this is
And
like
it curves backwards.
This is an extreme case.
Yeah, that's a very
So,
good
yeah.
Yeah.
But how can you get like that type of thumb? You know,
It's
goes all the way
inherited,
back?
just like dimples are,
Yeah.
just like anything else.
I got a straight
I have, now my thumbs, yeah, I got hitchhiker's thumbs, but some of my other fingers are also kind of weird in shape. This one, especially, is like, I can't even set it flat on a desk.
Alright,
Is
so
that all
when
of
you,
them?
yeah, when you get your paper, you're gonna write the ones that you decided you possessed. So
Yep.
the recessive ones, you're gonna write those.
So, for example, for me, I would say that I had hitchhiker's thumb was recessive, right?
Yep.
And
No suction,
the cleft chin, yeah.
Okay, then you're gonna pick one of those to answer this question.
Yep, and then just talking with your partner about it and figure it out. It's kind of fun. I mean, it could be a lot worse. And then, what's the last part here? In class, we completed a bunch of Punnett squares. Complete the following Punnett squares and provide the genotypes and phenotypes ratios of potential offspring. So what would be the expected outcome if you cross 2 heterozygous tall pea plants?
Small video.
So if it's heterozygous, first of all, what's that mean, guys?
It's the
You should know this real fast at this point.
hetero.
Heterozygous.
Homozygous dominant, two
And
different.
recessive.
Yep. Heterozygous means it's showing 2 different forms of it,
Yeah.
dominant and recessive. Okay? I know for a fact that if you guys can interpret heterozygous, okay, one of each, and put those there, I guarantee all of you can fill out that Punnett square.
Yeah.
If you had it set up, right? I mean, I believe that's easy for you guys. You guys have shown that you can do that. Genotype ratio. What's genotype mean again? Don't let it overwhelm you. It's a
What
big
it shows,
word.
no, that's phenotype, what it shows.
Genotype's just the letters, guys.
Oh,
So what are our letters? We get 1, capital, 2,
upper and lower,
heterozygous or upper and lowercase, yeah, and 1,
double lower.
double lowercase or homozygous recessive. Good. Phenotype ratio. That's what it's showing, right? What is it showing here?
That, yes, 75% would be dominant,
Yeah,
and 25 would be recessive.
that's right. And tall
Or
pea
3 to
plants,
1.
in this case, tall pea plant is the dominant, and one of them would show up short, yeah.
Yep, so you
On
can
average.
use percentages or the numbers, either way.
Any questions on that? Cause I think you guys got that. You're gonna show us here in a minute. Alright, I'm gonna put you in groups real quick. But I'm gonna kinda just base it on where you're sitting. You're a pair? You two are a pair? You two? Let's see here. Let me choose one. Over here.
That means highly.
You with Kylie.
Who's with me?
Me.
Damn.
And then let's see here. How many do I have left? Alright. And then we'll say, John, you're gonna be up here with these two. Carly, you can join one group of your choice. You're welcome.